Hi, class. Let's talk about volume and density. So volume is about spatial displacement. It's about how much space an object fills. And so volume has a unit of meters cubed. So the unit is cubic meters, meters to the 3 power. And let's just do some examples real quick. If you've got a rectangular prism, what? What are you talking about? Rectangular prism. So a cube is a good example. But anything built out of right angles, the formula is, so you got some box-like thing. It's got some length, some width, some height. So the volume is length times width times height. And of course, all those things are, the units for all those things are meters, so the end result is cubic meters at the end. Let's just do some common shapes that you might run across. It's like a sphere. A sphere is this three-dimensional object, not a circle like on the paper, but a three-dimensional sphere. But it's also characterized by a single radius from a central point. And for a sphere, the volume is 4/3 pi r cubed. So that's a good shortcut there. And one more shape. Let's do a cylinder. The cylinder's volume has to relate to its geometrical shape. So a cylinder has a circle on the top and bottom. And so you got a circular area up there, and that can be characterized by radius as well. And then you kind of grow that circle up and down some height. So that shape there is a cylinder. And so the volume of the cylinder is the area of the top, which is going to be pi r squared, times the height, like that. So cylinder volume's not too hard either. The other thing, density. Let's go on to density. So volume and density are our two topics right now. Density is usually given the letter rho, and that's the Greek r. So I think in Greek it's the R sound, and I suppose if I can't write, so if we say rho, RHO, I think is basically the way we English speakers spell that, but it's like a curly P, something like that. Anyway, density is mass divided by volume, and so its units are kilograms per cubic meter. And we've had density before, so this should be no huge surprise. The density of water, let's put a rho there, rho water is something like 1 gram per cubic centimeter, or 1,000 kilograms per cubic meter. And I put that older unit there because that's where things started, and it's of course a convenient unit for a lot of for when you think about it. The density of steel is varying according to the type of steel, but it's usually roughly about 8 grams per cubic centimeter, which is 8,000 kilograms per cubic meter. And maybe one more, density of air at standard pressure, so down here at sea level or something, best just kept in metric units, normal metric units, 1.29 kilograms per cubic meter. So density of air is quite a lot lower than these other things. Note, you can take this formula for density there, which is a good thing to box up, and you can easily rewrite the mass of some object of uniform density as the density times the volume. So that's a good thing to box up too. So mass can be summarized as density times volume. Okay, volume and density, very good.